Hello people, in this video tutorial I would like to introduce to you the two icons called tie and tie detection in the connections tab of the 3D Experience release 2022 native FEA solver. And as a reminder, that native solver is the Abacus program, well-known Abacus program. So I will do that. I will do this for people who are new to the 3D experience, or possibly they want to transition from the Abacus CAE and learn how to do things in the new interface, which is developed in the 3D experience. So the connections tab happens to be in the module, and there is the icon which says tie, and there's another icon in there. This is a folded uh, list of icons. It's called tie detection. Okay, and I will do that in the context of the following problem. Suppose we have the geometry is very simple. Suppose we have three blocks like that, which are somehow perfectly bonded together. Aluminum, steel, aluminum. The dimensions are given there, and the properties of steel and aluminum or elastic properties are given here. So we're going to model this thing as an assembly of three parts: aluminum, steel part, and aluminum part. One end is clamped and the other end is subjected to a pressure of 100 MPa. Now we are assuming that these interfaces are perfectly bonded, and that's where the name tie comes from. So for meshing, I have put some numbers here that I'm going to be using. Okay, this is for the steel part. The other one is for aluminum, the two ends. Okay, and we're going to ask the software 3D Experience to do an automatic tie detection. Basically, it is possible to pick these tied surfaces yourself, but you can also do a tie detection. That's where that other icon is handy. And so I will leave this thing here for your reference, because after I create my assembly, there are 9 planes there that I would like to hide them just for aesthetic purposes. Either you have to do this thing 9 hide planes one by one, or you can go to each part and basically uh, hide the 3 planes in that part automatically. And that's the reason I left it here. Uh, Now, when we do the analysis, the deflection that's predicted by 3D Experience based on that tied connections is going to be 0.167 millimeters. And you can do this. This is a very simple problem. You can do this hand calculation. So basically, you have 3 springs in series, axial springs in series. Each spring is going to have a stiffness of AE over L. A is the cross section, E is the material Young's modulus, and L is the length. So when you find the stiffness of 3 springs in series, you get an effective spring stiffness for all 3 of them put together, and then you take the force and divide it by Kf, effective stiffness, and you get 0.168, which is pretty much exactly what you got up there. Now, as far as the stresses go, the stresses look, I mean, kind of awful. But if you refine the mesh, you'll see that generally speaking, the stresses are correct. It's 100 psi. It should be 100 psi. But at the interface, because of that tied node connection, and the fact that the Poisson ratios are different, material properties are different, there is just different. There is a discontinuity there. Okay, but okay. So I have also put here some documentation from the 3D Experience that releases online, things that are available. So here's defining ties, some important points there, and this is the tie detection, the automatic one that we're using, and that's pretty much it. So let's go ahead and do this problem. So I have an assembly here because I'm going to do this thing as an assembly problem. It's going to be we're going to insert the first part. Oh, I'm sorry. This I did the assembly design right there. So let me close that. Already a product file has been created. Right click, insert a 3D part. That's what I want. All right. So let's make it. Let me call this thing right click properties. Properties. So I will say left aluminum. How about that? Left. How about left block? That's aluminum, of course. Okay, let's make it. So to make the part, I go to part design. This is generative shape design. So let's switch to, oops, let's switch to part design right there. Now we're in part design. So for example, on that plane, on that vertical plane, exit plane, I will sketch. I will sketch a 10 millimeter by 10 millimeter 10 millimeter by 10 millimeter square. That's the cross section. So this is 10, and here is another one, also 10, and exit, and padded by 50 millimeters. Padded by 50 millimeters. That's the first block. Okay. And then uh, what do we create the material for this thing? So so we go to tools, uh, tools, uh, create a material. I'll call it aluminum block. Aluminum block. All right. Let's apply it to this part. Right click, apply. We don't need this anymore. We can apply it to that part. And now we're going to input the properties. So aluminum block, left aluminum block. You see that it's right there. Okay. Double click on this branch. And it's a structural problem. Abacus, multiphysic, mechanical, elasticity, elastic. And 200, oh, this is aluminum. So it's going to be 70,000 MPa. I've already changed the units, and the Poisson ratio is 0.29. In all likelihood, that red this discrepancy between the stresses on the two sides, one means the stress, has to do with the Poisson ratio, this Poisson ratio. So if the Poisson ratios of the two material are made the same, probably you won't get that sharp red interface. Okay, that takes care of this. Now we're going to insert. We go to the we go to our product right there. Right click, insert the next one, next 3D part. That's going to be the middle steel block, right? So let me change this thing properties, and I'll call it middle steel. Middle steel. And there are different ways of doing it. For example, I'm going to do it like so on that face. On that face, you can create these parts separately and then put it together with assembly constraints. I'm not doing that because that's not really the purpose of this tutorial. So on this face, we're going to actually let me go to the part that I want to make here right there. 3D for steel, middle one. Okay, on the Excel plane, or actually let's make it on this plane. I will sketch on this plane. I will sketch again a 10 millimeter by 10 millimeter square. Remember, there are easier ways of doing this thing, more efficient ways. That's okay. I'm doing it like that. And yeah, okay. So let's do it. can project surfaces and things like this. Okay, so let's make a dimension here, 10, and this is also 10. All right, exit. Okay, and then pad it. Flip the direction, 50 millimeters. Okay, this is going to be steel. It's going to be steel, and just so that you can see it, I'm going to change the color of that. Properties under graphics. Let's change the color to brown or beige. Okay, good. And now we're going to create a material for it. So we go to tools, create a material. I'll call it middle steel. What do I call the other one? Middle. Yeah, the other one I call left block. Okay, so middle block. How about that? Middle block. Yeah, middle block. Okay, no, that's fine. Middle block steel. How about that? Just so that I remember. Okay, so middle block steel. Right click, apply. Get rid of this. Apply to this middle part, and we're going to put the properties in it. So expand this. Double click. Structures, multi-physics, mechanical, elasticity, elastic, and this is steel, so 200,000, 1, 2, 3, and Poisson ratio I'm told is 0.3. Okay, good. All right, so we go to the product. Let's save this thing. And then we're going to insert our third one, so it's the right block. Okay, right click, properties, sorry, right click, insert, ah, no. Okay, let's try it again. Right click, insert, 3D part, it's right there. And let me call this thing a right block. That's the aluminum block, of course, right? Properties, just so that we can see on the reference. Yeah, it's going to be right block. Okay. Let's make it. So we go to the part design by double clicking on 3D shape here. Again on the XZ plane. Actually not on the XZ plane. On this plane, it's easier if I did it like that. See on that plane, I'm going to sketch. You know what, this time I'm going to do it differently. Instead of drawing something here and, you know, dimensioning it, I'm going to say project this face. Okay, so we can see it's already made. And we exit. And we pad it. So pad in the other direction, 15 millimeters. Good. Okay, on this, we're going to apply the aluminum properties. So we go to tools, browse the material browser. Let's find that aluminum thing that we created. So that was here, aluminum block, right? Right click, apply. There are other ways of doing it. So that's really not the point of this tutorial. Okay, very good. So that, let me save everything. We now go and mesh these things. So we go to the structural model creation. Let's do a empty FEM. Okay. You wait for this dialog box to show up and you say that I want all three parts to be meshed. Okay, all of them to be participating. So we say okay. And now we're going to do a sweep meshing of this first one. Yep. So 3 millimeters and 2 layers. Let's look at it. Actually, it was the other way around. So let me cancel that. Okay. So swept meshing. Swept meshing. I don't want it to be swept like that. So why don't I say manual sweep? So for example, the source, I'm going to select it to be this side. Well, the support, of course, is this piece. So for source, I'm going to say this side. And for the target, it's going to be, of course, the other piece. Right click, hide this. Okay. So I think the size in the slide I said 3 millimeters, and the number of layers is 2. So mesh, there we are. Okay, good. We close that. Now notice that the mesh has been created for this. While we might as well do the properties on it. So we go to properties, 3D solid section. We select this whole thing. This whole part, aluminum is picked. We say OK. Now we have to repeat this thing for the middle section with properties being steel and the one on the right. We might as well, now that this is, well, yeah, we might as well do that right now, now that it's hiding. The other one is hiding because we need it. So let's go do another, under meshing, we do another sweep. This time, this is the body. And we're going to do a manual sweep. And the source is going to be this. Oh, it's already picked. Okay, this is already picked. Based on what we did a minute ago, this is already picked. So mesh it, and there we are. Oh, except that the size was wrong. This size should have been 3, and the number of layers should have been 2 mesh, and there we are. This is the aluminum. Might as well do the properties also. So properties on the 3D, we select this. The whole body is aluminum is picked. Good. Now let's go and bring the middle one into the show mode. Let's see, the path may be hiding up. Right click, hide and show. Very good. Now these things we don't want. And well, okay, so let's go ahead and do this mesh. Okay, so sweep, that is the one. Hopefully it picked the, let me hide this. Yeah, that's good. It's going to sweep it like that. 3 millimeter. Actually, for the steel part, if you go back to the slide, when I say slide, I mean, let's see now. This for the steel piece, it's 6 and 4. Okay, so let's go ahead and make it a 6, and number of layers is 4. Mesh it. Okay, there we are, and we say OK and apply the properties. So properties, solid on this part. Notice that the middle block of steel is selected, and we are good. All right, to show everything here, let's use the right-click visualization manager, visibility manager. So let's see our mesh for everything. Yeah. Okay, so this was the finite element. Let's see it. There we are. Now the other guy is probably hiding, and let me see, why is that hiding? Path, right click, hide and show. There we are. Okay. And if you want to see the mesh, of course, on it, so you say, show me the mesh, all of them. You see something is hiding here. Yeah, this one is hiding. Okay, there we are. All right, now we don't want to see the part anymore, so we just hide this. Okay, that takes care of our mesh. So we now go to structure scenario creation. Let's use the finite element model that we created for this assembly. Incidentally, you can see that there are 3 swept meshes and 3D solid properties, and this is basically that portion of the sheet that you see here. Okay, and now we're going to have to first of all decide on the procedure. It's going to be static step. You know, it really doesn't matter, but what I'm going to do is I'm going to say we don't want to include the nonlinear geometric effect in. It really doesn't matter. Okay, it's going to do it in one shot. I didn't even change the starting increment, the maximum increment, etc. So it's just going to do it in one shot as a linear problem. All right, very good. So now as far as the restraints is concerned, restraints, this end is clamped. This end is clamped there. And on this other end, we apply a pressure of 100 MPa. So for load, this is pressure on this face, put down minus 100 MPa. Minus because you want it to be tensile. All right, obviously if I run these two, it's going to bomb out because these are not connected regions, okay? So here is what we're going to do. We go back to our model. There's the model. I could have done that thing. I forgot to do it, but I could have done it before. Remember when I was meshing and when I was setting up the properties, there's this connections tab that I could have done it there. So I go there, and so I went back to this model, okay? Uh, and here we have the tie, and on the connections tab, tie and tie detection. So we're going to do tie detection, okay, for the whole model. And you can use the geometry or the find the ties. Oh, okay, find the ties right there. Find the ties. Find the ties. Like, okay, so you're right here, engineering connection right there. So don't forget that you say find the ties that are created here, and that's pretty much it. So if I go to visibility manager and I say okay, let me expand this thing. Oh, the connections. Let me see them, if any, right there. See that? I went to the visibility manager, I selected connection and said show it to me. So it found tied nodes here. Okay, tied nodes. All right. And that's pretty much it. So let's go ahead and run it. So we go back to scenario. Remember, I could have done this thing when I was doing the meshing. I forgot, so I ended up going back to the model and created my ties. So let's go ahead and simulate. First of all, model check. Okay, we do simulation check. This is if you have some obvious errors that are going to pop up in the model and scenario check. We're going to see it ahead of time before it runs. So make sure you have your engineering connections when you do this tie detection. And the key was that you have to ask for find the ties, okay, in that radio button. I don't anticipate any problems. And then you can do a mesh refinement later on yourself if you're interested to get a better stress distribution. Instead of that, you get something like this. Okay, there is a warning here. That's okay. And then we're going to run it. These two red dots, these two magenta dots indicates that things are tied together there. Remember, we're doing a linear analysis, so it's very fast, and I did it in one shot by saying that minimum time is 1, and minimum increment is 1, and maximum increment is also 1. So we'll do it in one shot. And I also deactivated the area jump radio button because that's really not the purpose of this tutorial. I just want to show you how to use the tie connection and tie detection connection. It will be done in just a minute. Okay, extracting results. Hopefully we get 0.167 millimeter, 0.167 millimeter of deflection. Yep. So this is 1 meter stress, but this is the first increment, right? This is the final. Oh, this is the 1 meter stress. Yep. Yep. That is what you got here. Okay. And for deflection, displacement will be 0.167. Okay. Hopefully you found this thing useful.